Hello students. Today we are in chapter 16 looking at consumer choice. We're going a little bit out of order with the chapters. We did chapters 1 and 2 first, but now we're jumping to 16 before going to chapter 3. There's a good reason for that. Chapter 3 is about supply and demand. However, demand comes from consumer choice, so it made more sense to me to tell you about consumer choice first, so then we'll know the origins of demand. So, here are our topics. We'll define something called utility, and then once we have that in place, we'll look at optimal consumption. As always, remember to turn on the subtitles in case the homework password is in there somewhere. Alright, so what is utility? Loosely speaking, utility is the amount of satisfaction you get from consuming. So I said loosely speaking because that definition is not 100% accurate. If you're going to take intermediate micro, you might get a more exact definition. However, it is a good way to form some intuition understanding of what's going on. So this is the definition that we'll work with in this course. So the units of utility are utils. So here is an illustration of what that could mean. I clearly wrote this slide before COVID because back when I was writing the slide, there were still live concerts and you could go to movie theaters. But anyways, back in the pre-COVID days, perhaps you got 31 utils from going to a concert and 17 utils from the movies. So the concert gives you more utils. 31 is bigger than 17, so that means you prefer the concert over the movies. So we model consumers as trying to maximize their utility subject to a budget constraint. So we know if you give people everything they want, they'd ask for quite a bit, and that's just not going to be feasible. We said you can't satisfy everyone. So you got to do as well as you possibly can within the confines of your budget. Now, perhaps you're thinking, I don't know what my utility function is. Well, neither do I. So here is the justification for using utility functions in economics. Though I don't know my utility function and you don't know yours, we both behave as if we have one. So a major justification for this came from a famous economist, Milton Friedman, who made this comparison to the game of billiards. So I'm not quite sure how expert billiard players do what they do. I have never played the game, and if I were to try, I'm pretty sure I would not be an expert in my first try. Now, if we don't understand what they're doing, how can we model it? Well, the expert billiard player plays in the exact same way as someone who is solving these really complex mathematical equations, looking at optimum directions of travel and all that kind of stuff. They act in the same way as someone who knows a lot about physics, even though they might not have studied physics at all. Now, if you go to watch a billiards game, you're not going to see them working on big notes of paper working through these complicated math equations. However, the actions they take might be the exact same actions as someone who is solving all that math. So while I don't know what's going through their head when they're playing billiards, I can write down equations that give the same result. In the same manner, we can turn to your economic decisions. When you go to the grocery store, you don't see anyone working through complicated calculus trying to figure out what they should be buying. Even the economists in the grocery store aren't doing that. However, you make choices that are identical to someone who is doing that. So maybe when you went to the grocery store last time, you spent $6 buying bananas and chips. Now perhaps with some level of prices and some budget, someone who has the utility function bananas raised to the power 1/3 and the square root of chips might have made the exact same decision. So I don't know what's going on in your head when you bought those bananas and chips, but I do know that someone with this utility function always makes the same choices you do. So I model you as if you had that utility function. So even though no one's consciously going through all this math when they're buying stuff, they always act as if they are. So I can model them with these mathematical equations. So that's why it's valid to use utility functions to model economic decisions, even though no one actually knows their true utility function. So let's be careful here to avoid some misconceptions about utility. One thing to watch out for is that you cannot compare utility across different individuals. So your book says that everyone has their own unique scale for utility, which is a good way of thinking about it. People have different preferences, and that scale can look different for them as well. So if in some situation Dennis is getting 5 units of utility, so 5 utils, and Sunny is getting 8, don't conclude Sunny is happier. That'd be comparing utility across individuals, which we just said is invalid. So maybe 5 utils for Dennis on Dennis's scale could be higher than 8 utils for Sunny on Sunny's personal scale. So you can't make conclusions about who's happier than who based on their utility numbers. So another thing to watch out for is maybe having the same action. You're both consuming an apple, and Dennis gets 65 utils from that, while Sunny's only getting 30 utils. Don't conclude that Dennis likes apples more than Sunny does. You can't assume that. Again, their personal scales differ. You can compare utility for the same person making different choices, but not for different people. So in case you're wondering, if no one knows what their utility function is, then how do we work with them? It turns out if you watch people make a lot of choices, you can deduce their utility function. So we can't measure it directly. There has been a lot of excitement about things with brain scanning devices and some of the neuroscience stuff that's been developing. However, last I checked, they're still very, very far away from actually being able to measure your utility function. So we can't get a direct measurement. What we can do is watch what you pick over time and what you chose at different prices and different budgets. And eventually, you can piece together a utility function from that. So the actual math behind it's rather complicated and not something we discuss here, but it is doable. So let's say I give you a choice. I can give you a free concert ticket or a free movie ticket. And this is all pre-COVID when movie theaters were open and you could go to live concerts. And let's say you pick the concert ticket. So I don't have enough information right away to put together a full utility function for you. However, you did give me one piece of the puzzle. I now know that because you picked the concert over the movie, that the concert must give you more utility than the movie does. So that choice revealed your preference. We distinguish between preferences, which are all in your head and not observable, and choices, which we can observe. Because your preferences inform your choices, we can deduce your preferences by watching your choices. Now, there is some misinformation about utility functions and happiness. Like I said before, utility is not exactly happiness, it's a little bit imprecise. So your book, unfortunately, perpetuates some of those myths by using happiness surveys as a substitute for utility. There's a number of well-known flaws with happiness surveys. The short answer is that happiness surveys are basically garbage. Here's why. So Gallup is a well-known polling organization, and they have this, I think it's a daily tracking poll. They ask people a number of questions, one of which is, how happy are you about your life overall? So one day they decided to change the order of questions on the survey. In particular, they took out some question about the how satisfied are you with today's politicians? Most of the time, people are pretty upset about politicians, so if you ask them about that, they can put them in a bit of a grumpy mood. So once you put them in a grumpy mood and you ask them about their overall happiness, you get a lower number than what you would have gotten otherwise. So when Gallup chops out this one question from their survey, overall lifetime happiness soared. That doesn't sound right. This one question about politicians should not have a big impact on your overall lifetime happiness. It might affect your happiness in that one particular moment, but they ask you about overall lifetime happiness, so that effect should have been pretty negligible. So that indicates that the order of the questions can substantially change the results. So happiness surveys are not reliable. You have some surveys that try to compare happiness across countries using these garbage happiness surveys, so those results, like I said, are garbage. There's another survey where they put the subjects in two groups. So one group has made some copies on a copy machine. The other group they had set up so they're also making copies on the copy machine, but they set it up so that they happen to find a dime in the copy machine. So 10 cents should be pretty negligible in the grand scheme of things in overall lifetime happiness. However, in the survey, the people who get this extra 10 cents are so much happier overall in their whole lifetime than people who did not. That also doesn't sound right. There's more evidence about the order of the questions or other things that really shouldn't matter end up mattering. One survey asked about how happy are you, and they asked how many dates have you gone on, and then the other version they asked about dates first and then happiness, and you get substantially different results for overall lifetime happiness being influenced by something that happened within just 1 month. So trying to compare happiness across countries or across individuals with the happiness survey, very unreliable. There's also been attempts to include happiness alongside other economic indicators, like looking at, for example, gross domestic product, which you might learn about in principles of macro. So it could be things like gross domestic product plus happiness plus environmental quality plus other things. So a lot of these other things can be hard to measure, and how much importance do you assign to, say, environment versus GDP is a pretty subjective question. And different people are going to give you different answers about what's the right way to weight those. And the happiness component is pretty much nonsense, as we just saw. And also the author who is putting together this index has their own biases that come with them, and that's going to influence the results. So, big surprise, if you ask French economists which country is #1 in the world, they're going to say France. So what they probably did is, consciously or unconsciously, it might not have been deliberate, they set up their index with weights in such a way that their preferred country came out on top. So a lot of these alternatives to GDP that try to incorporate happiness and other factors are biased and not reliable, and happiness surveys are also very unreliable. Your book talks about them, but just ignore that part. Alright, so now we know what utility is and what it is not. Now, we talked about the 5 foundations of economics back in chapter 1, and one of those foundations was marginal analysis. We distinguish between total and marginal. So marginal is how much of the total change if you add one additional unit. So marginal utility would be how much extra utility you get if you consume one more. So let's say if you watch one movie, that gives you 12 utils, so 12 units of utility. If you're to go and watch a second movie after that, your total utility would rise to 20. So now we can calculate your marginal utility. So if it went up from 12 to 20, that's an increase of 8. That means your marginal utility is 8, the change in utility when you watch one more movie. Once again, I should be clear that I'm being a little bit imprecise here. The actual definition of marginal utility involves calculus, but that is not a prereq for this class. Those of you who take intermediate micro will be seeing a more calculus-based definition, which is precise. For now, though, we'll stick to this definition. So in the case of movies, marginal utility is how much extra utility you get when you watch one additional movie. So here's a table of how many movies you see and how much utility you get overall in total. And we already established that if you go watch a second movie after a first movie, your total utility rises by 8. 12 plus 8 is 20. So with that in mind, go ahead and fill in the rest of the table. So pause the video here and work on that. Once you think you have found a solution, press play and we'll see if you're right. Alright, I'll assume you've worked through the problem by now. So here's the rest of the table. So when you see 0 movies, you're getting 0 utility. That rises to 12 when you see a first movie, so the marginal utility of movie number 1 is 12. 0 plus 12 is 12. I gave you this one here, 12 plus 8 is 20. If you watch a third movie, total utility goes up to 22. That's an increase of 2. 20 plus 2 is 22. If you watch a fourth movie, though, you spent an awful lot of time on the couch and feeling pretty lazy and drained, so now your utility is going down. So it falls from 22 to 15. That's a decrease of 7, so marginal utility is minus 7. 22 minus 7 is 15. If you watch the fifth movie, that's a tremendous amount of time on the couch. You're going to lose more utility. 15 minus 9 is 6. So as you watch more and more movies, the marginal utility starts going down. Now total utility at first keeps going up, but it goes up at a slower and slower rate. You gain 12 utils from that first movie, but then the gain gets to be smaller, just 8 utils with the second movie. With the third movie, you've only gained 2 utils, and by the time you get to movies 4 and 5, now your utils are actually going down. They're actually in negative territory for the marginals. So this is true not just for movies, but actually it's true much more generally. We call this a law of diminishing marginal utility. So diminishing marginal utility is a very, 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 very big deal in economics. This is not just one thing you hear in part of one chapter and then forget it. You'll hear about this in just about every econ class you ever take. This is important. So we can draw a graph which shows it more visually. So we said that we had 0 utility from 0 movies, and one movie gives you 12 units of utility, 12 utils. 2 movies gives you 20, and 3 is 22, and so on. So you can see how the graph curves like that. And the marginal utility is just graphing this last column here. So with our first movie, our total utility went by 12, so marginal utility was 12, so we had 112 over here. Utility rose by 8 with the second movie, so we graphed that over there. And for the third one, it was an increase of 2, so we have 2 for the third movie. And you see you always have a negative slope for marginal utility. Now, to be clear, what diminishing marginal utility means, we're not necessarily saying that total utility starts going down like this. That's not always true. What we are saying is that marginal utility goes down. So this slope should always be negative. So as you can see, total utility can still go up, but at a slower rate. And that can still be consistent with marginal utility going down. You can see marginal utility getting lower and lower, even though total utility is just rising at a slower rate. So I used movies in my first example, but it applies to so much more than that. That's why it's called the law of diminishing marginal utility instead of just that one weird example of diminishing marginal utility. Let's talk about televisions. If you have 0 TVs, then buying your first TV could give you a lot of utility, could make you much more satisfied, give you a lot of entertainment. So the marginal utility, the extra utility you get from buying one TV, could be a lot. Now, if you already have 5 TVs and you decide to buy a 6th for some strange reason, that's going to give you very little extra utility. If you have 5 TVs in your small dorm or apartment, then you have more than enough TVs per room, so adding a 6th TV doesn't really do a whole lot. So you're still getting one extra TV, but if you have 5 already, the value of that extra TV is a lot less than the value of your first TV. So marginal utility goes down as you have more TVs. Now, I'm not saying you get unhappy because you had more TVs. Maybe your total utility is still going up, but the extra happiness you get, the gain to your happiness, is going to be really small. Your book talks about utility in the context of eating brownies. So after a meal, having a brownie for dessert sounds like a pretty tasty idea. Now, if you've already had 10 brownies and you're thinking about eating brownie number 11, you're pretty stuffed and have a lot of sugar in your system. So the extra utility of that 11th brownie is going to be pretty small, perhaps even negative. Might even make you worse off to have an 11th brownie. Why did you decide to go to college? Well, it must have been that you thought that would raise your utility. So getting your first degree is going to presumably raise your utility. You'll be happier than you would have if you had not gone to college at all. Now, if you already have 7 college degrees and you decide to go back and get an 8th degree, the extra utility there probably not going to be a whole lot. So the more college degrees you have, the lower the value of getting one more. One college degree is good, but even getting a second degree, like a double major or double degree, could also be pretty good, but past that doesn't seem terribly satisfying. Not going to do a whole lot for your happiness. And another slide is obviously written in the pre-COVID days when you could still go to live concerts. So maybe your favorite band is having a concert nearby on the weekend and you can go to live concerts again. So buying tickets for that and going to that one concert might give you a lot of utility. However, if they're staying in the area or doing a couple of concerts on the weekend and you've already seen 4 of them, hearing the same songs again a 5th time on the same weekend might not give you a whole lot of extra happiness. So the marginal utility of your first concert could be pretty big, but marginal utility of concert number 5, not so much. So this idea of diminishing marginal utility has some very ancient roots. Way back in the book of Proverbs, it says, "One who is full loathes honey, but to one who is hungry, everything bitter is sweet." So if you've already eaten a lot of honey, then the marginal utility of having even more honey is not that big. It's kind of like the person who had 10 brownies already and they're thinking about brownie number 11. Not terribly appealing anymore and way less appealing than the first brownie. Now, if you're very, very hungry, even something that sounds really not that tasty could sound very appealing to someone who's famished. So it shows that principle that the more food you've already had, the lower the marginal utility of having even more food. So I mentioned this earlier, but let's go into a bit more depth. So diminishing marginal utility does not mean that your total utility falls. It just means that it could go up at a slower and slower rate. So as one example, we can talk about a coin collector. The coin collector always likes having more coins. They never have enough. Now if you have 49 coins already and you're getting a 50th coin, the coin collector is still happy about that. They're still gaining more utility. Total utility is still going up and up and up. However, the excitement they had when they added their very first coin to their collection was definitely bigger than coin number 50. So you can see here, much bigger gain to utility in the beginning than there was out here once you've already had quite a bit. So total utility is going up and up, but at a slower rate, and that is still consistent with diminishing marginal utility. So here is total utility. If you were to graph marginal utility from that, you get a picture that looks like this, and that is steadily going down. So the point is that marginal utility will always have a negative slope, and that could mean that total utility goes down, or it could mean that total utility goes up at a slower rate. That's what diminishing marginal utility is all about. So let's pause here and we'll continue with the next episode, and we'll look at some possible objections to diminishing marginal utility.